the main thing here, it kind of makes sense. You got some dude. He's standing here, right? And what's he going to do? He's going to look up at some airplane that's flying in the sky. All right? Well, he just went up. So that's an angle of elevation. That's so many degrees that he raised his eyes. All right? Now, what's going to mess you up on these diagrams is you're not going to calculate the angle of inclination and the angle of depression correctly if you don't stop and think about the horizontal line. All right, the angle of elevation, like he's standing, so his vision straight out is a straight line, and it's the horizontal, and you measure from that line. All right, and what happens is when you have pictures that you just draw random triangles for, not a person standing looking at something, what happens, let me go with a different color here, is people try to measure this entire angle as the angle of elevation, because this would be a straight line down here, and then maybe whatever the different dimensions and things that they give you, but people will mistakenly measure this as the angle of elevation, and it is not. It has to come out from this horizontal, and it's just going to be this tiny one right here. Okay, same thing here, angle of depression. What do we see? We see that horizontal line. Okay, and this time he's looking down at an object. Okay, so angle of depression. Okay, so they will refer to those in some of them. Now, is that going to be in absolutely positively every one of our story problems? No. We're going to go from very simple story problems that need nothing more than a trig equation, all right, and then to something that needs law of sines, and maybe law of sines followed by law of cosine. So you may have to implement 2, 3, 4 things that we have done, okay? All right, so this first one, this is going to be a straightforward one, okay? You've got a surveyor that can measure the width of a river by setting up a transit at point C on one side of the river, taking a siding at a point A on the other side. After turning through an angle of 90 degrees at C, the surveyor walks 200 meters to point B. Using the transit at B, the angle theta is found to be 20 degrees. What's the width of the river? Okay, so we're going to, on every one of these, we're going to draw a picture. Okay, so I think what I want to do is I think I want to let you try to draw a picture first. Because if I just automatically draw the picture, okay, well, then that's the hard part. Okay, so you read that, see if you can come up with a label a point A, a point B, a point C, draw you a cutesy little river, and see if you can put the 90 degree where it goes, see if you can put the 20 degrees where it goes. And everyone's picture does not have to be identical as far as how you draw the river. Okay, we got a bunch of pencils that have stopped. Okay, so I changed my river. I did a crooked river to begin with, and then I'm like, no. So I changed it to a horizontal river. Okay, so angle C was the 90-degree angle. Okay, so turned and went 200 meters to B. The angle formed there by setting up the transit was 20 degrees. How wide is the river? Okay, so whether or not you have a river on there, it doesn't matter. I add the rivers because it's cutesy. That's about it. Okay, how many people have the right angle at 90? C. Angle B is 20. And the distance between B and C here is 200. So this one, straightforward. Right triangle, okay? Right triangle. We've done right triangle trig, right? So what's my equation? If I want to try to find B, all right, I've got, this is my reference angle. What two sides do I have? I've got the, what's this side over here? Opposite side. And what's this side over here? Adjacent. So I've got my opposite side. I've got my adjacent side. Which trig function is opposite over adjacent? Tangent. So I've got tangent of 20 degrees is opposite over adjacent, which was B over 200. So then there's your equation. Okay, so if we need the opposite over adjacent there, that's fine. We can put that on there too. And then we did this not too long ago, and you just used your calculator. You went ahead, you solved, you multiplied both sides by 200, and then you put 200 tangent of 20 degrees in your calculator, all as one big fail swoop. All right, nothing's rounding, and then it does its magic. It needs to be in degree mode, so make sure the calculator is in degree mode. And then see what B is. So B is about 10, 20. 72 point, I don't know, 79. We're going out two places. And I believe the story problem was meters. Okay, so if you were able to draw the picture, all right, and then write the equation, then you should be good. This is your straightforward type of trig story problem. Okay, straightforward, not hard. All you have to do is write a single trig thing. Okay, so are we good on the easy one? Okay, now let's do a little more challenging one. And maybe this one's not. This is a little bit more challenging only in the sense that you got to do a little bit of subtracting. All right, so on the next example here, I'll go ahead and zoom in and we'll talk about it first. All right, a straight trail leads up to an alpine hotel, elevation 8,000 feet, to a scenic overlook that is at 12,000 feet. The length of the trail is 14. What is the inclination or grade of the trail? Okay, so in other words, what's the angle of elevation? Okay, so attempt to draw a picture. I'll let you do that for a minute and see if you can come up with the right picture. Okay, do we have a picture? Still got pencils moving, but I didn't know if that meant you were just working out the problem after you draw the picture or not. Okay, so I got cutesy. I put a little hotel in my picture. Okay, I'm not drawn to scale. All right, so they told me that there's this hotel and it's at 8,000 feet elevation. Okay, so here's the hotel. All right, the incline, all right, that goes up to a scenic overlook. My scenic overlook is up here somewhere, so it's up like walking up the side of a mountain. All right, they said that that distance was 14,000 feet. They said the elevation up here, the elevation at the scenic overlook is 12,000 feet. All right, so as of initially from my picture, that's all I've got. Okay, so did everybody come up with the right angle, right triangle? Did we have 14,000 on the hypotenuse? Okay, the angle, the inclination or the angle, the grade of the trail is going to be this angle down here is what I'm looking for. Okay, now looks like this is going to be a straightforward trig equation. All right, but I have to come up with another side. So what's the side length of another side? What's the side length of another side? I know the hypotenuse. Can I find this side at all? I can't find this side at all, right? Because I know nothing about it. Can I find what the distance is here by subtracting those two, right? So that side's got to be 4,000. Okay, so I'm just going to write 4,000 in blue. So the only thing that made that one a little bit different is you had to actually subtract those two numbers to figure out what that is. Okay, let's see. Here's my angle, my reference angle. So this is the opposite, and this is hypotenuse. Okay, so which trig function, opposite over hypotenuse, is sine? Okay, so then I've got sine of theta is 4,000 over 14,000. So there's my trig equation. All right, now I'm probably going to do a little bit of reducing just so I don't have huge numbers, cross off zeros. 4 over 14 is like 2/7. So I might go ahead and reduce that to 2/7. Not that it makes any difference. I wouldn't have had to have done any of that. It makes the numbers smaller. Okay, now I'm trying to find the angle. When I go backwards and I try to find the angle, which button on the calculator do I hit? Inverse. So I'm doing the inverse of sine of 2/7. And then that should give me my angle. Okay. And we're doing everything in degrees here, so that makes theta roughly 16.6 if you're in degree mode. 16.6 degrees. All right, so those first two story problems, straightforward, write a trig equation, but you can't write the trig equation if you can't draw the right picture. Okay, so you got to be able to draw the picture appropriately. Okay, now we need to step it up, do a little bit more challenging one. All right, on the next example, I didn't write the story problem out. All I did was draw the picture for you. Okay, so let's look at that. Now, obviously, I'm going to tell you, you're going to have to do more than one thing. All right, doing one equation is not going to get you the answer. Okay, so ultimately the question is, how tall is the building? Okay, so the height of the building, that whole distance right there. All right, but see how I got these little people down here, and their line of sight, these are angles of elevation, so the person's line of sight goes straight across here. But I need this whole distance right here, so I'm going to have to be sure and include the height of the person, because everything we do that we calculate is going to be based on that 47 and that 35 degrees. Okay, so we're going to have to think this through. Okay, so let's come up with some different variables here. Let's take this picture and let's make a right angle right here. Can I come up with the angle measure that's right there. Because that's from geometry, right? Straight line, 180 degrees minus 47. I don't know what that is. All right, 180 minus 47. So 133. So this angle down here is 133. Does everybody see the dotted triangle right in here? I have these two angles, right? Can I come up with that little one right up there? Because I can add them up and subtract from 180. So 133 plus 35 minus 180 is going to give me a 12 degrees up here. Okay, now why am I filling in all these angles when I need lengths of the sides? Okay, well, because what I'm thinking is I drew this right triangle here. So I could use right triangle trig on this to get the distance from here to here, and then I could just add 2. That'd give me my whole distance. Okay, but to be able to do right triangle trig on this right triangle right here, I need another measurement. I need a side. So I could find that side right there, then I'd have opposite over hypotenuse. I could use a sine. Okay, now to find this one, I'm going to have to consider this triangle here. All right, now that I've filled in all my angles, see this 50 down here? It's kind of pulled down away, but that makes this side 50. So if I know a couple angles in one side, then we can do the law of sines to find this distance right here. So that's going to be step 1. Okay, so let's do law of sines on that. All right, I'm going to zoom out because if I don't, then I'll mess up here. Okay, so step 1. I'm going to do law of sines. And I'm finding x is what I'm finding. So from that picture, let's see. I'm going to have the sine of the 12 degrees over the 50. Okay, so sine of the 12 degrees over a 50. All right, now I want the x side so that I've got my right triangle trig here. So I'm going to go sine of 35 over x. And then that's going to let me cross multiply down, solve for x there. Okay, but of course it's going to be a rounded value, but that's okay. All right, so 50 sine 35 degrees is equal to sine 12 degrees times x. Divide both sides by that sine of 12. So 50 sine 35 degrees over sine 12. And that'll give us a rough estimate there of the distance of that hypotenuse. I'm going to check my math just to make sure I'm doing everything right. Sine 12. Okay, so did we get roughly 137.94? Okay, so 137.94. Okay, now if you wanted to be really, really accurate, you take that great big long decimal and store it in a value in the calculator and then retrieve it. Okay, that would prevent you from rounding in the middle. But if you don't want to go to that much trouble, we'll go ahead and use the 137.94. Okay, so I'm going to write on the diagram. That's a 137.94. Okay, now I've got right triangle trig. I would love this distance right here. And I can't use an x. And this is h, so I'm going to use a y. I got to pick another letter. I've already used x. Okay, so step 2, I'm just going to use right triangle trig. Okay, so we said this would be opposite over hypotenuse. Opposite over hypotenuse is sine. So then I'm going to have sine of how much? 47 degrees is equal to a y over 137.94. We'll be off a little bit because we rounded that value. On the you're all using the graphing calculators. Technically, I can just pull down that answer. I don't even have to store it. I can pull down the answer and multiply it by sine of 47, and it'll keep it in there. Do you guys know how to pull that answer down? Okay. So then I got roughly 100.88. Again, just rounding it roughly. And that's the distance from the top of the tower to that line of sight. And then since it said that the guy's about 2 meters, then all I got to do is add 2 meters to that. So that's my step 3. Add the height of the guy. So it's 102.88, roughly. And is this meters? I think it's meters. So 102.88. So that's the part that's going to make it a little bit more challenging, because you're going to have more than just one thing. You may not always just use a right triangle trig, but I did use right triangle trig here, but I used law of sines here. So I can use law of sines, which is probably going to be the vast majority of what you do is law of sines and trig. All right, just basic trig equations. Okay. All right, and you haven't done any of this in physics. Okay. It's a good thing we're practicing. All righty. Okay, now let's see. What's the next one? All right, typically, in these type story problems, you're going to see some dimensions that you've got to know how to read. And I don't know if you've done these. If you haven't done them in physics, you probably haven't. All right, let's just take a look at that first. North, 40 degrees east. Can you all read that? Do you understand what direction that is? North, 40 degrees east. All right, you all know north, south, east, west, right? Okay, so like, oh, how could I zoom in and out too many times here? So if I want north, 40 degrees east, here's north, and then I'm going to turn 40 degrees east. Okay, so that means that this angle right here would be 40 degrees. Okay, so I could do a variety of things. What's another one in there? North 30 degrees west. Okay, so north 30 degrees west. All right, well, here's north, and if I go 30 degrees towards the west, that would make this angle right here 30 degrees. Okay. I could do south. Let's just stick with 40 and 30. 40 degrees east. All right, well, here's south. And then if I go 40 degrees east, I'm rotating up this way. So this angle in here would be the 40 degrees for south, 40 degrees east. Okay. All right, so you would have already learned that in physics. Okay, so now let's go back to this. All right, rescue station A is located 150 miles due west of rescue station B. Okay, so roughly 150 miles apart. All right, a ship sends an SOS call that is received by each station. Okay, so some ship out there. A call to station A indicates that the ship is located at north 40 degrees east. The call to station B indicates that the ship is located at north 30 degrees west. How far is each station from the ship? Okay, so first of all, we need a picture. Do you want to do the picture on your own? You're all shaking your head no. You don't want to try this one on yourself? Okay. All right. So, I got station A, station B, 150 miles apart. So that's what I'm going to start with. Okay, so here's A, and here's B, and they're 150 miles apart. So that was the easy part, okay? Now, it says the call from station A indicates that the ship is north 40 degrees east. Okay, so let's put an imaginary north line on there. Okay, and it says it's north 40 degrees east. So I'm going this direction towards the east, because up here would be north. Over here would be east. Okay, so then, right there's where my ship is. Let's make it a sailboat. There's my sailboat. Okay, and if it's north 40 degrees east, that means this angle is 40 degrees. It said that the station B indicates that the ship is north 30 degrees west. Okay, west would be over here. All right, so station B got the call. We're going to put the imaginary north line in there just so we can see it. All right, and it is 30 degrees west. So towards the west. So when I draw the line to the ship, this dimension right there has got to be 30 degrees. Okay, so far so good. That's all that they've told us. Now, what's the thing? How far is each station from the ship? All right, so if this is B, capital B, then this side over here would be little b. And if this is capital A, then this side over here would be little a. All right, so station A is going to be B away from the ship. Station B is going to be A away from. So I just have to find those values. Okay, now, so far, what have I got here? What could I calculate some other values that would be of use? I made a 90 degree up here. So can I find some other angles? Okay, right here's a 90 degree angle. So if this one is 40, then that means this angle has to be 50. So we calculate that on our own. They didn't give us that, but it's extra information that I can do because this is a 90 degree angle. Okay, over here, again, I got another 90 degree angle because that's my north. We turn to the west. If that's 30, then that makes this angle right here 60. Now, can I find B? Do I know enough? I'm not going to be using a right triangle trig because I don't have a right triangle here. Okay. Do I need another number before I can use something that I already know? Is there another number I could find really quick? I could find that one up there, right? 50 plus 60, like 110 minus 180 is going to be 70 up here. Okay, so now I know all three angles on the inside. I've got an angle and a side. Whenever I have an angle and its opposite side, that should say, hey, I need law of sines. If I know an angle and a side, I can do law of sines. All right, I want to find how far station A is away. That would be little b. Okay, so for station A, I'm going to use law of sines. We'll put that in parentheses. All right, so I'm going to go ahead and do the sine of 70 over the 150. Since I'm trying to find little b, because that's the distance station A is away, I'm going to have sine of 60 over little b. So this is a law of sines because I don't have a right triangle. Okay, cross multiply down. Should be pretty straightforward. I'll let you cross multiply down, and we'll see if we get the right answer. Alright, so did we get roughly 138.24? Going out two places. Okay? And I believe the question just says how far is each station. Alright, so station A is about 138.24 miles away. Okay, and you ought to be able to then go ahead and calculate a similar law of sines for station B. We definitely want to use the 70 and the 150. Sine of 70 degrees over 150 for that. And then if I want station B, which is going to be side A, I'm going to use sine of the 50 over the A. And then I'll let you cross multiply down. Okay, did we get roughly 122.28? Okay, and then, I mean, I guess if you want to add miles to both those, you could, because it is a distance. And I didn't really draw it to scale. I didn't mean to draw it to scale. However, that distance is longer than that. Kind of looks that way on my picture. So, I got lucky. All right, now, law of sines, right triangle trig, and then you're going to have some other random questions. Read question B. Part B says, if a helicopter capable of flying 200 miles an hour is dispatched from the station nearest the ship, so if it's from the nearest one, which one's closer? B is closer, okay, so it's being dispatched there. How long will it take to reach the ship? Does this have anything to do with trig? Has nothing to do with trig, right? What they give you? They give you a rate. You know how far it is. They want to know how long. What are those three things? Rate, distance, time. Rate, distance, time. Please tell me you know a formula that has a D and an R and a T in it. Oh, please. A distance and a rate and a time. Distance, rate, time. Really? This was... I've got a distance, I've got a rate, I've got a time. Has anybody shown you distance equals rate times time? Not in a while. Okay, because like if you're driving 50 miles an hour and you go for 6 hours, how far did you travel? Right? So, real simple. Science formula, distance equals rate times time. This has nothing to do with trig. All right, are they going to throw maybe a part B or a part C in the question that has nothing to do with trig? Yeah, they could. All right, because we know those things. All right, so which ones do we need? We need, it's 200 miles away. No, he's going 200 miles per hour, so that's my rate. They're asking for time, and we said the distance for B. The distance for B is the 128, 122, 28. All right, one-step equation. All you gotta do is divide. The 122 helps if your calculator's working. So time, 0.6114. So less than 0.6 of an hour, because that was the rate was miles per hour. So less than an hour.